This is Computer Programming 1 from the University of Washington. I'm Martin Dickey, and I'd like to welcome you back. Our topic is structuring program files. Now that we know quite a bit about programming, it's time to step back and look at how we can put the pieces together to form a program. Some of this material may look quite familiar, but I think there will be one or two new topics of interest as well. Before we knew about functions, we had to assume that a C program was just a series of declarations and statements. Actually, programs are collections of functions. Most programs are not a single main, but they may consist of dozens or hundreds or even thousands of individual functions. This is the way programming is done. Some of these functions may be defined within the program you write as part of the algorithm you're trying to express. Others may already exist and live in libraries that you want to have access to. So being able to organize and put all of this material in a coherent order is an important part of writing a large program. When we talk about putting things in order in the program, there's a general principle that applies to many things, not just to functions. And that is that identifiers have to be declared before they can be used. Identifier is just a fancy word for a name. All we're saying is we have to know what the name is, what it refers to, before we can begin using it. This is true for variables. We always place the variables first within each function. Then we can use those variables in the statements of that function. For pound-defined constants, we generally put their declarations at the very top of the program so they can be used in all the functions. Now, what about the functions themselves? If I have many functions that make up a program, what order do they need to be in? Well, the general principle of having to define an identifier before it's used applies to functions as well. In this program, I have three functions declared: function 1, fun2, and main. Now, peeking inside function 1, we see that one of its statements calls function 2. So here I want to use function 2 inside function 1. Using that general ordering principle I just mentioned, this would require that function 2's definition appear before function 1 in the program file or the source file. The same logic holds for main. Main wants to call function 1, so you need to put the definition for main after the definition for function 2. So the name of the function will be known at the time you want to call it. Now, you might already think that this is inconvenient. In fact, if you've been writing programs with functions, you may have already discovered this restriction and found it annoying. Sometimes it's just inconvenient, or it doesn't read logically to a person to have the functions defined in such strict order. There are also going to be some cases, if a program uses a feature we'll talk about much later called recursion, where function A might call function B, and function B might turn around and call function A. In this case, our ordering rule seems to provide an impossible stumbling block. Is there any way around this? And thankfully, the answer is yes. The answer is we can use a function prototype. What this facility does is let us define that function name early in the program. Once the name is defined, we can call the function without having its full definition. In this early definition, or prototype, all we need to mention is the function name, its return type, and the types of the parameters, because these are exactly the things that the compiler needs to know about in order to process a call to the function. We don't have to give the code for the function. Instead, we will end the function prototype with a semicolon instead of a series of statements in curly braces. Here are some examples. They look exactly like the beginnings of functions, except there's no code. The first function is called useless, appropriately enough. Takes no input, returns no value. This is not the full function definition, and we know that because there are no statements. As a minimum, a function needs to have an empty curly brace. But here we have a semicolon instead. So useless is being defined by a function prototype. Later on in the program, we'll have to provide the actual code, the statements that make up the function useless. The second function, printInteger, has one integer parameter and no return value. The second one has two double parameters and a double return value. If we put all our function prototypes at the top of the program, then we're free to call them in any order we find convenient or that we find is logical for a reader of the program. Eventually, somewhere in the file, we'll have to provide the full definition. Let's summarize what I've just said. Write the prototypes for the functions near the top. Generally, they only take a line or two of space. Use the functions, that is, call them anywhere thereafter, and then define them wherever it's convenient or stylistically appropriate for you. This is very highly recommended for program organization. Now, this helps with the programs that we're writing and defining and creating for our programs. But what about a function like printf, which is in the library? The rule holds for printf too. We cannot call printf if the compiler doesn't know that it exists. The identifier has to be known before the function can be called. But you're not going to write the function printf. The statements are never going to appear in your program. So what can we do about that? To solve this problem, we'll use the include directive, #include. It goes at the top of the file or close to the top of the file. And what it tells the compiler is that there's a file named stdio in the case of our example, containing information that should be interpreted just as if it were written physically in the program. Now, what's in that file are many things, some of which we might discuss in a lecture on I/O. But for our purposes, one important thing is prototypes for functions like printf and scanf. So by including a directive #include stdio in that program, you have instructed the compiler that we'll be using a library and that it contains a function with a prototype of printf and scanf and any other functions in that library. What about the code? Well, the code won't be in that #include file. It's already been compiled. The compiler doesn't need to process it again. The linker, however, will do that. This picture, refresh our memory on the process of building our program, will show at what point the library comes into play. The program that you write, the file we're talking about organizing today, is a .c file toward the left-hand side of the screen. The compiler processes that, turns it into ones and zeros. If there are no errors, the linker then takes that and combines it with other already compiled programs. And those already compiled programs might include libraries such as stdio. Finally, the linker can produce an executable that can be run on the computer and executed. Summarizing the order that elements ought to appear in a source file, a .c file, start with #include directives. You may have several if you're using more than one library. Then place any #defined constants that take part in the statements in your program. Following this, put the function prototypes. This not only helps to document the functions, but then makes it more convenient and later on not to have to worry about their order. Eventually, you have to write the full function definitions. And if you have prototypes, you won't have to worry about the order in which you do that. Now, it might appear that the order in which you put the functions in the program would affect the operation of the program. It doesn't. It doesn't affect it at all. The order of the functions within the source file doesn't affect the control flow. Control flow follows rules that depend on the operation of the statements. In all C programs, control flow starts at main. So there always needs to be a main function. And it doesn't matter where in the file that function is located. The system will find that function main and start execution there. Now once you're in main, control flow depends on the types of statements that you write. The sequential flow occurs unless there's something to break that flow, such as conditional statement, such as a function call, or any of the other things we've studied which affect the flow of control in a program. Okay, since programs are collections of C files, it's important to know how to organize those files and to know what your options are. This general principle of identifiers being declared before they're used is helpful here, and you'll find it helpful again in other places in programming languages. For functions, we can define a prototype, declare it near the beginning, and put the function definition anywhere convenient after that. For libraries, we shouldn't forget to mention the library name in a #include directive at the top of the program. Finally, keep in mind that the order of functions in the source file is different from the control flow during execution. I think you'll find these concepts helpful as you continue to build ever more complex, elaborate, and interesting programs.